In this video I'm going to illustrate how it is possible to add together spectra of pixels from two imaging datasets. Now these aren't exactly imaging datasets as they stand, because these represent a series of spectra that were measured at different stage positions. So these are really spectral datasets with spatial information. Now we can take advantage of the spatial information to reorder the information within these two datasets so that they can then be added on a pixel by pixel basis. And that's what we want. If we're going to add this spectrum to this spectrum, we must have the same pixel adding the spectral data. So let's convert these into images rather than leaving them in the form of spectra at pixels. It'll involve using the imaging processing dialog window and images from pixel spectra. So I select my VAMAS blocks that I'd like to create a new dataset from that will represent images, and then I press the button and I end up with a new data file. And here we see an image, and that image is at a given Raman Shift, and then I have a set of these, and now I've got the signal in a form where I can correlate positions with one another. If I go back and then do the same operation, namely create a new image dataset from the other file, I just need to make a little adjustment to the heading because they both came up with -20, and I need to have them different. So I'll set this one to 1. That's one data file, and let's do the same for the other one, which is here, and we'll make that the second one, so I'll call that 2. So now I've got a column of images separated in Raman Shift, and I've got two files. Here's the other file, and I'd like to combine them, and I can do that by copying the selected VAMAS blocks that I'd previously selected, and when I combine them in a data file, you can now see I've got images where the spatial information, or the intensity at pixels, is now correlated to a point where I could add these images and produce a new image that will have the sum of these pixels with a given energy, and I'll have a whole set of energies with different images from which I could then calculate other information such as the mean spectrum. So let's perform that operation. Now to do this, the button that works on data in this format is on the spectrum processing dialog window. So although these are image data, some of these buttons actually work for imaging data, and this is one of them. So sum sample ID active tile. So this is telling me that I can sum any VAMAS blocks with the same sample ID. Now, I'm not sure I have all the same sample ID here, so what I'll do is, because I've got them selected, I will now adjust the sample ID. So the only tick box here that I'm going to have ticked is the update sample ID. So that means this field here, I'll call that Raman image, and update all the selected VAMAS blocks. So now I know I've got the same sample ID in all of these VAMAS blocks. I'm now in a position to use this button. I'll say sum by row, meaning that this VAMAS block will be summed with this VAMAS block to produce a new image that will be associated with this energy. So let's do that. And a new file is created. And here we have a set of images that now represent pixels that have been constructed by adding the corresponding pixels from the two different data sets. Now, if I want to construct an average spectrum, there is a button that says Profile Image Statistics, and these statistics are the mean, the standard deviation, and the min and max. So overlaying the images in the active tile before profiling the image statistics, that will produce a new VAMAS file that gives me the mean spectrum, the standard deviation, and the min and max. So that's an example of how to combine information based on spatial information that can relate back to spectral information.